All right, we're going to start talking about rational number powers, okay? So we talked about, just to review the previous video's content, we talked about a rational, irrational number. How do I classify them? And then we talked about mixed and entire radicals. And we're going to take those two things and sort of combine them when we talk about radicals as powers, because radicals as powers become rational numbers, all right? If you want more practice, you can review in the textbook on page 221. You should have access to that online. So in terms of exponents and radicals, we want to be able to talk about powers with both integral and rational components. You should be fairly well versed in the integral part, but we want to talk about what happens when we're talking about radicals as powers. How do we convert them into powers? So what we do is, you remember hopefully that this is called the index of the radical, that little number there. That index, when you write it as a power, becomes a denominator. Okay, so that's the index. That's where it goes. If there was a number in here, let's say it was a to the m, then you would have m up here. Okay, but if it's just a number, like the cube root or the square root, it becomes a fraction. Now it also works in reverse. So if I start it with 16 to the 1/2, the index is 2. Okay, or the index is 3. All right, so it becomes the cube root of 27 or the square root of 16. So we want to be able to evaluate these without using technology. In other words, we want to be able to recognize what this means. So 27 to the 1/3, we just said that's the cube root. Index comes from the denominator, and then of 27. So we know that that's the cube root of, if you prime factor this, again, it's 3 times 3 times 3. So it's 3 cubed. And the cube root of 3 cubed just becomes 3. Okay? 0.49 to the 1/2, we write that as the square root of 0.49, and hopefully recognize the square root of 49 is 7. So the square root of 0.49 is 0.7. Okay, that's one you should know. Minus 64 becomes the cube root of minus 64, again, because the denominator of the fractional exponent or fractional power becomes the index. And then you may not recognize that 64 is minus 4 cubed. Minus 64 is minus 4 cubed, but if you prime factor it, you take 2, right? And that's 32, and then you can keep going down 2 and 16 and 2 and 8 and 2 and 4 and 2 and 2. Okay, so if we make groups, we have 2 and 2 here. Sorry, we need to make groups of 3. So we have a group of 3 there and a group of 3 there. Okay. So it's 2 cubed times 2 cubed, or just 4 cubed, because 2 times 2 is 4, if that makes sense. It's 2 groups of 2 cubed, so it ends up being 4 cubed. You don't have to do all of that, though, if you just recognize your powers of 4. And what I would encourage you to do, because they're going to show up a lot, is to list your perfect cubes. So not just your perfect squared, but your perfect cubes. Now you don't have to go as high necessarily, but 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, okay? And you're probably not going to see much more than that. But 6 cubed, if you think about it, it's 36 times 6, okay, if you're wondering where I'm getting these from. So 6 times 6 is 36, 6 carry 3, and then 6 times 3 is 18, plus 3 more is 216, okay? And you can do more than that, but usually you're going to see these ones pop up, all right? So it's just a matter of recognizing your perfect cubes. And then that gives me minus 4. Then we have 4/9 of this 1/2. That becomes the square root of 4 over 9. And when you're doing that, you're going to split it, so it's the square root of 4 divided by the square root of 9. And the square root of 4 is 2, and the square root of 9 is 3, so it becomes 2/3. Okay? That's how we work with rational powers. Now, what happens too is that we said if you have a number on top of the fraction, it proceeds to be raising that whole radical to that power, or raising the radicand, the thing inside the radical, to that power. So we can write 40 to the 2/3. We take the denominator, right, cube root, and then all squared, or we can write it as the cube root of 40 squared. Okay. Now, this way, we're going to go backwards. All right, so if this becomes the numerator, I'm going to write a fraction. It's going to be 3 to a fraction. This becomes the numerator, so 5. And this, which is the index, is going to become the numerator. Now, it's not written there, so it becomes a 2. For this guy, we have 25. This is the numerator of my fraction. This is the denominator. So I get to the 2 over 3. Okay? So it's 25 to the 2/3. Oops, 2/3, sorry. 25, not 2. So that's how we would write that in exponential form. Okay? Then the question asks us to evaluate some of these. So what we're going to do is just write it as the square root of 0.04 cubed. And that becomes 0.2 cubed. And that becomes 0.008. All right? If you're not sure, you can do it on the calculator as well. Let me just get my calculator out here real quick. So you can take 0.04, take the square root of it, and get 0.2, and then you just raise it to the 3rd power. Okay? So you can use a calculator. Down here, I'm going to write that as the cube root of 27 to the 4th power, right? So the denominator became my index, and then this goes outside. The cube root of 27 is 3. We know that from previous question. And then 3 to the 4th, again, you can do it on your calculator, or you can recognize it is 81. So those are my answers. And that's how we work with rational powers.